Today we're talking about percent of increase and percent of decrease, both of which are percents of change. When we're calculating a percent of change, we're trying to find the percent that a quantity changed from the original amount. So we take our new amount, subtract the original amount, and when we find that difference, we're going to divide it by our original amount. We will get how much the percentage changed in decimal form. Now, a percent of increase is when the original amount has increased to get to the new amount. So let's say we had a plant that was 12 centimeters and it grew to be 18.5 centimeters. That's an increase. If we're trying to find the percent of increase, we're going to follow this formula, and our answer should come out to be a positive answer because we have an increase. A percent of decrease is when an original amount decreases. So one day I have 20 students in class, the next day I have 15 students. So maybe some got sick, maybe they're absent for different reasons, but this is a decrease. If I use my formula to figure out the percent of decrease, my answer should turn out negative because the percent has decreased. A percent error is when you estimate an amount, and then when we find out what the actual amount is, we figure out your amount of error, how much your guess was off, and divide it by the actual amount. So let's actually see some of these concepts in practice. Let's look at some examples. So first we're going to find a percent of increase. So this table shows the amount of time that you spent online last weekend, and they want to know what is the percent of change in your online time from Saturday to Sunday. So Saturday is our original amount and Sunday is our new amount, and I can see that my online time is increasing. So I'm expecting a positive answer here. To find the actual percent of change, I do my new amount minus my original amount divided by the original amount. So my original is Saturday because that's the first day. So my new amount is Sunday. So I'm going to do 4.5 minus 2 divided by 2. 4.5 minus 2 gives me 2.5 over 2. And if I actually divide these, 2.5 divided by 2 gives me 1.25. So this is my percentage in decimal form. To change a decimal into an actual percentage, remember I moved the decimal 2 spots to the right. So I actually have a change of 125% here, and it's a 125% increase. So it's over 100% because my time from Saturday to Sunday more than doubled. If I had spent 4 hours online on Sunday, that would have been a 100% increase. I'm over that. It's a 125% increase in the amount of time I spent online from Saturday to Sunday. Let's look at a percent of decrease. So here we have a bar graph that shows a softball player's home run totals, and they want to know what was the percentage of change between the years 2012 and 2013. So we would take the new amount minus the original amount divided by the original amount. Now the original here is going to be 2012 because that's the one that came first. So in 2013, this softball player had 20 home runs. I'm going to subtract my original amount, 2012, they had 28 home runs, and divide by the original. So 20 minus 28 gives me negative 8. Divided by 28 gives me negative 0.28571422. And it probably continues on, but that's as much as I can see on my calculator when I divide these. So I'm going to round my answer to the nearest tenth. So I am going to change this into a percentage by moving the decimal over 2 spots. And this would be about negative 28.57142. So if I'm rounding to the nearest tenth, I'm going to say it's about 28.6. So it's about a 28.6% decrease. And I know it's a decrease because the answer was negative. So the amount of home runs she hit decreased by about 28.6% between 2012 and 2013. Let's look at one more example, finding a percent of error. So you estimated that the length of your classroom was about 16 feet. Then we measured and the actual length was 21 feet. So we want to find the percent of error. So your guess was off here by 5 feet. I got that by doing 21 minus 16. So you were off by about 5 feet. Now, the actual length was 21 feet. So I do my error divided by the actual. And that gives me, on my calculator, about 0.238095. I'm going to change this to a percentage by moving the decimal over 2 spots to the right. So that's about 23.80952. And I'm going to round my answer to about the nearest tenth. So here I have a 23.8% error. So I was off in my guess by about 23.8%.